Hello students, you are welcome to today's lecture on principle of electrical measurement. Remember, in study 67, you have learned that an electric circuit can be described by circuit parameters such as resistance, current, and voltage. The question is that how can these parameters be measured? Basically, there are a number of measuring devices that can be used to measure these parameters. For example, a multimeter, otherwise known as multipurpose meter, can be used to measure current in ampere, voltage in volts, and resistance in ohms. Other electrical measuring devices include moving coil, galvanometer, potentiometer, and Wheatstone bridge. When you have studied this session, you should be able to explain the effect of internal resistance on the terminal potential difference of a battery in a circuit. Also, you should be able to explain the working principles of a galvanometer and its uses. You should be able to describe conversion of galvanometer into ammeter or voltmeter, and explain the working principle of potentiometer and Wheatstone bridge. And in the end, you should be able to solve problems using working principle of a potentiometer or a Wheatstone bridge. In this part, we are going to concentrate on the first three learning outcomes. When current flows around a circuit, energy is not only transformed in the external resistor, but also in the cell itself. Virtually all cells have a resistance of their own called the internal resistance. As depicted in figure 8.1, a cell produces a voltage called electromotive force E, which in turn produces a potential difference V across the cell, and the external resistor R. The EMF E, the external resistance R, and the internal resistance small r of the DC circuit in figure 8.1 are thus related by expression E equals to IR plus IR. That is, the electromotive force E is equals to the product of the current multiplied by the external resistance R plus the product of the current and the internal resistance small r, where E is the electromotive force measured in volts, I is the electric current measured in ampere, R is the external resistance measured in ohms, and small r is the internal resistance of the battery measured in ohms. The quantity of electrical energy available outside the cell, that is, the useful energy, is the first parameters, which is the product of the current I and the external resistance R, and the product of the current and the internal resistance small r is the energy transformed to other forms within the cell itself. That is, I multiplied by internal resistance R is the energy lost in the cell, usually in form of heat. As you have already known that every electrical element, such as battery, no matter how well it's been made, is not perfect and has some resistance called internal resistance, denoted by small letter r. As battery ages, it chemically degrades and the internal resistance of the battery increases. This causes the EMF of the battery to decrease. That is, the voltage decreases. The exception is superconductors, which have exactly zero internal resistance. Exercise 1. The internal resistance of a battery is dash proportional to the EMF of a battery. So you are to check the answer to this question at the end of this lecture. Now, ammeter, voltmeter, and multimeter. The instruments that are of most use to the physicist and the electrical engineer are the ammeter and voltmeter. Ammeter is an electrical measuring device which is used to measure electric current flowing through the circuit. An ammeter can either be digital or analog in nature, as shown in figure 8.2. An analog meter is a meter with a scale, while the digital meter is a meter with where the readout is in number. However, in order to use an ammeter to measure current flowing in a circuit, you must connect it in series to a circuit as shown in figure 8.3. Also, voltmeter as shown in figure 8.4 is an electrical measuring device which is used to measure potential difference between 2 points in a circuit. Voltmeter is always connected in parallel to a circuit as shown in figure 8.5. You can also use the data you read from both the ammeter and the voltmeter to get resistance. That is, the resistance is equal to volts divided by amperes, and the power is equal to volts multiplied by amperes. Figure 8.6 shows how a multimeter can be used to measure parameters of an electric circuit. And a multimeter, as you have known, is a multipurpose measuring instrument which is often used to measure parameters such as resistance, voltage, and current, but not all of these parameters at the same time. Galvanometer. Galvanometer, as shown in figure 8.7, is an electromechanical instrument which is used for the detection of electric current through a circuit. Being a sensitive instrument, galvanometer cannot be used to measure heavy current. It can only be used to measure currents which are in the order of milliamperes, that is 10 to the power minus 3 ampere, or millivolts, that is to measure voltage in order of millivolts, that is 10 to the power minus 3 volts. In a moving coil pointer type shown in figure 8.7, a coil is pivoted on geoid bearing between the poles, within the poles of the magnet, and current enters and leaves the coil by air spring above and below it. When current flows, a couple acts on the coil, causing it to rotate until it stopped by the springs. The greater the current, the greater the deflection, which is shown by a pointer attached to the coil. The sensitivity of galvanometer can be increased by having more turns on the coil, using a stronger magnet, using weaker air spring or a wire suspension, or by making use of a light pointer. Now, how can we use a galvanometer as an ammeter or voltmeter? Since galvanometer is a very sensitive instrument, therefore it cannot measure a potential difference or current. That is, it cannot measure a high potential difference or current. So in order to use galvanometer as a voltmeter, a very high resistance called multiplier, denoted by Rm, must be connected in series to the galvanometer as shown in figure 8.8. From figure 8.8, by applying the techniques for resolving resistors in series, which you have learned in study session 7, this means that the total voltage V of a circuit is given by V equals to the current I multiplied by the resistance of the galvanometer plus the current I multiplied by the multiplier, that is the resistance of the multiplier. By factorizing I out, since the resistances are connected in series, therefore the same current will have to pass through the resistance. Therefore, in this case, V is equal to I into brackets Rg plus Rm. From this equation, V is the total voltage in the circuit, I is the current flowing in the circuit, and R subscript G is the resistance of the galvanometer, and Rm is the resistance of the multimeter. Note, if resistors are connected in series, the current flowing through the circuit will be the same. In order to use galvanometer as an ammeter to measure heavy current, a very low resistance known as shunt, denoted by R subscript S, must be connected in parallel to the galvanometer as shown in figure 8.9. From figure 8.9, by applying the techniques for resolving resistors in parallel, therefore the total current I flowing in the circuit is given by I equals to the current flowing through the galvanometer plus the current flowing through the shunt resistance, which is equals to the voltage V of the arrangement divided by the resistance of the galvanometer plus the voltage V of the element divided by the resistance of the shunt. From this equation, I is the total current flowing in the circuit, V is the voltage in the circuit, and I subscript G is the current flowing through the galvanometer, and I subscript S is the current flowing through the shunt resistor. Also, R subscript G is the resistance of the galvanometer, and R subscript S is the resistance of the shunt. Now, let us solve question on conversion of galvanometer. Example 1. What is the value of a resistor that must be placed in series with a 25.0 ohms galvanometer having a 50.0 microampere sensitivity in order to allow it to be used as a voltmeter with a 10 volts full scale reading? Question 1b. A galvanometer can be used to measure high current by connecting a resistance called dash in dash to the galvanometer. So solution to example 1. From example 1, the given parameters are the resistance of the galvanometer, which is equal to 25.0 ohms, the current of the flowing through the galvanometer, which is called the current flowing in the circuit, which is equal to 50.0 microampere, which is equal to 50 times 10 to the power minus 6 ampere, since 1 micro is equal to 10 to the power minus 6. And total voltage V in the circuit is equal to 10 volts. From the question, the unknown parameter is the resistance of the multiplier. In order to obtain the resistance of the multiplier, recall V is equal to I multiplied by the resistance of the galvanometer plus the current I multiplied by the resistance of the multiplier. So therefore, in this case, V is equal to 10 volts, which is equal to 50 times 10 raised to the power minus 6 ampere into bracket 25.0 ohms plus Rn. This implies that 25.0 ohms plus resistance of the multiplier is equal to 10 volts divided by 50 times 10 raised to the power minus 6 ampere. By making the resistance of the multiplier the subject of the formula, Rn is equal to 0.2 times 10 raised to the power 6 ohms minus 25.0 ohms, which is equal to 200 kilo ohms minus 25.0 ohms, which is expressed as 199.975 kilo ohms, which is approximately equal to 200 kilo ohms. That means the correct option there is option C. From equation 1b, the galvanometer can be used to measure high current by connecting a resistance called shunt in parallel to the galvanometer. The correct option is option B. Now, you can take this exercise 2 to test your knowledge on how to convert a galvanometer to ammeter or voltmeter. Question exercise 2a. How can a galvanometer be used as an ammeter? Exercise 2b. A galvanometer with a coil of resistance 12.0 ohms shows a full-scale deflection for a current of 2.5 milliampere. How will you convert it into an ammeter of range 0 to 2 ampere? And how will you convert it into a voltmeter of range 0 to 10 volts? Note, after completing this exercise, compare your answers to the correct answers provided at the end of this lecture. If you made one or more mistake, you need to review the use of galvanometer as an ammeter or voltmeter section and solutions to the questions in example 1. Thereafter, try this exercise again. We have come to the end of this part 1 lecture on principle of electrical measurement. I hope to meet you in part 2 lecture, which focus on working principle of potentiometer and Wheatstone bridge and how to use their working principle to solve problems. Bye for now. Thanks for listening.